This is the ancient history, and ancient and medieval history, should I say, lecture for Tuesday, the 12th of October, 2021. At the end of class on Friday, and just now today, we saw excerpts from Walking with Monsters, Life Before the Dinosaurs, a BBC series that mixes CGI and live effects to show what life might have been like, according to the theory of evolution, during the Paleozoic Era and in the period leading up to the development of the dinosaurs. What we saw on Friday were pictures of the Paleozoic seas during the Silurian period and the development of the world's first fish. And what we saw today was during the Devonian period, where there was so much oxygen in the air. Almost a third of the air was oxygen. Today, I think it's 5 or 10% at most. What is it?
I think it's like 11% in nitrogen.
Yeah. So oxygen is about a tenth of the atmosphere, and the rest is an inert gas called nitrogen. And there's a reason why this is a good thing. Yes.
Wasn't the plentiful oxygen in the air the reason why everything grew to be so big?
Yeah, you can get giant insects if they can, since they breathe through their skins.
Imagine if we lived back then.
Yeah, it would be bad. Well, that's why guns are a good thing. If you ever go back in time to that era, bring guns, because you'll need them.
And a spoon.
And a spoon. Although I don't think you really want to eat bug guts. Then again, lobsters are really good.
Yeah.
So I lived in Maine for 23 years. So yeah,
I don't know.
That's a very good one.
Right there.
Think about how hungry the first guy in the world to ever eat a lobster must have been, because it doesn't look appetizing. Yeah.
So my dad and I were born in Maine, and so what we do is we order live lobsters from Maine.
Yeah.
Every time his birthday comes around, and then we just cook them at our house.
Yeah. So they arrive in ice.
Yeah.
Yeah. We've only done that once since moving out here. My wife grew up in Maine. She was there from the 4th grade on. I went to college in Maine, and then we moved back there again for 23 years, young adult. We used to eat at a lobster pound that had, it was right on the shore of the ocean. So it had ocean water pumped right in. And, if you go to Red Lobster around here, the lobster tank, they're sort of dull, dead, stunned, zombie-like. Not in the places we used to go. They were active. They would fight one another, and they'd have little dramas because they were getting fresh seawater pumped in, and that's what they're evolved to deal with. Oh, but fresh lobster is incredibly good. I'm glad you have a chance to have it.
Yeah.
Where in Maine was your dad from?
I think I was born in Bangor, and I'm pretty sure he was born there too, or in that area.
Yeah, my wife was from Searsport, which is just south of Bangor. We lived mostly northwest of Portland, so we were farther south and farther west than you guys. But beautiful state. Happy I'm here, but beautiful state. Miss many things about it. So the atmosphere itself combusts. Make sure you have open notes in front of you, the notepad. The atmosphere itself catches fire when there's lightning. So it's not bad enough that you're going to have a lightning storm. That lightning storm takes on the aspect of an artillery barrage because the air goes. So one of the effects is the giant insects. The other effect is the exploding air. Luckily, the proportion of nitrogen increases, of oxygen decreases, and that's why when you light a campfire, you don't burn your face off, which you would have done back in the Devonian. The air itself might have caught fire. Small fun fact, I guess you'd call it. When they were testing the first atom bomb at Alamogordo, New Mexico, there was a theoretical possibility that it could have combusted the atmosphere. All of it. That a chain reaction would have caused the air to burn everywhere on Earth. But it was a pretty small chance, so they rolled the dice on that one and detonated the first atom bomb and the second and the third. Second over Hiroshima, the third over Nagasaki. But there was a chance. That's a serious gamble. That you might actually end up in a situation where you burn the oxygen out of the atmosphere. Yeah.
So if you basically launched a nuclear weapon in that time, basically the whole world.
Yeah, it would. Yeah, life on Earth, at least above the water, would have died out. By the way, I have to ask you because of uniform. So, where are we in terms of our notes? We are on item 39, let's see. Yeah. We had been working through the various iterations of invertebrates, soft invertebrates, the jellies and worms, invertebrates with exoskeletons like shrimp and lobster and ammonites and trilobites, and then the development of the world's first spinal column, which is the central nervous system that makes information processing so efficient for us, and the development of vertebrae, which are ring-shaped pieces of hard matter. Now, the first vertebrates are sharks and rays. Sharks and rays don't have bones. They've got teeth, but they don't have a skeleton made of bone. Their skeleton is made of what your ears are made of. That's cartilage. They're cartilaginous vertebrates. Sharks and rays have the wobbly part of your nose and your external ears. So their skeletons are more flexible than ours, but less rigid, less strong. Still, you wouldn't want to bet on a shark not having a strong bite because it's got teeth attached to jaws that are attached, cartilage. No, it'll still chop you up like a Thanksgiving turkey. Don't get bitten by a shark. Sharks and rays are among the first type of vertebrates, and then we have the development of the bony fish. Now, something about sharks. Sharks are one of the oldest ongoing forms of life that exist on planet Earth that are not insects. Sharks have not fundamentally changed since the Paleozoic Era. They were and are perfect eating machines in their environment. They swim, they eat, they breed, they swim, they eat, they breed. Now, sometimes sharks have weird fin shapes, and head shapes like the hammerhead, but in general terms, sharks are what they always have been. This oceanic predator. They're not always at the top of the food chain in the ocean, but they're always there getting what they need, which is meat from other living things. So we descend from, according to evolutionary theory, the bony fish. Now, during the late Silurian and early Devonian, life begins to come upon to the land. Plants, insects, other animals. And now we come to it. About 230, 240, 250 million years ago. So, item 39. About 420 million years ago, at the boundary of the Silurian and towards the Devonian, life adapts to expand into a harsher environment. That's going on land. Now, about 230 million years ago, it's actually 240, there's disagreement in my own figures, actually. The world experiences the Permian event. By far, the worst mass extinction ever in our planet's history. Over 95% of the species of life on Earth died. Just like that. Now, why is this mass extinction event? Why does it happen? We don't know. We have suspicions, but we don't know. Here's one of the things that happens. About the time of the Permian, Pangaea forms. Pangaea is a global supercontinent. All the world's landmasses are all smushed together. Now, in the interior of Pangaea, this creates a desert more arid than the Sahara. But it also disrupts warm water currents at the equator because this giant landmass is filling one side of the planet. And that means that the regulatory warm water currents that keep a global climate stable are gone. They're kablooey. And so it's possible that the temperatures in the oceans radically change so quickly that life can't adapt and most of it dies. Or there are a series of volcanic eruptions under the surface of the sea that causes a massive chemical poisoning. We do know that since most of the life that's killed in the Permian is aquatic life, that whatever happens really affects the sea more than it affects the land. So the Permian event kills 95% of species.
How do they know this ever?
They don't.
Well, actually, they do. It's a theory. They don't know it without doubt, but they theorize based on fossils. Now, there are two ways you can measure the age of fossils. One is by its place in the sedimentary layers. If it falls in a certain sedimentary layer, it's probably of that era. Because sedimentary layers always, I mean, at some point, if you leave this campus alone, it's going to be swallowed by the earth. Other layers of earth are going to just take it over eventually. The other way is by carbon dating, the radioactive half-life of the isotope carbon-14 in older bones. So what we do is we have a bunch of shell remnants from things like ammonites and trilobites from the time before the Permian event, which is called the Paleozoic Era. And then no more after that. That presumes a mass extinction. So that is the methodology that they use. Do either of you or anyone else have anything to add before we move on about that methodology? Yeah.
Two things. Is that when the dinosaurs died out?
No. Dinosaurs are not yet born. That's going to come later with a different and lesser extinction event. Do you have anything else? Okay. You said you piped in. No, they don't. What did you mean by that? If you don't mind me
Well,
asking.
I mean, this is like the creation myth, and they don't actually have any data about what happened then because nobody was there.
What they have is inferential data. They have the fossil record. They have records of soot and other chemicals in the sedimentary layers and in the fossil record. And what they do is they draw conclusions based on that very limited information.
But what height they were at does not necessarily determine what time it was when they died.
That depends on a reading of the geological record. It might not. It could indicate. But yes, a lot of the methodology is based on things being in the right layer. Carbon dating, though, is harder to fool, but it doesn't work on recent things. It's older. Yes?
Is there a possibility that 95% of the Earth could have been knocked out by a disease?
Entirely. If it was a waterborne disease, the thing is, this disease would have crossed species. Things as different as certain types of jellyfish, as ammonites and as trilobites, would all have to be susceptible to them. So it's possible that it was a disease agent, a virus. It's also possible that the early solar system got caught up in an interstellar war between space empires, and somebody got zorched by a death ray, and it was the Earth by accident. Whoop, we got in a line of fire. We honestly don't know. And frankly, I think it's kind of cool, the idea of, oops, there goes the Earth.
What is this?
Could have happened. What we tend to think is mineral poisoning due to a bunch of volcanic eruptions. That is the most plausible theory I've heard. What I can tell you is the Permian event is basically, there's a lot of types of life right before it, and right after it, there are very few. And they're in much smaller numbers. So that indicates a mass extinction. Next page. So now we are on item 41. The whole universe is expanding. We know that. 42. Okay. From about 3,800,000,000 years ago until about 248 million years ago, we have the Paleozoic Era, the era of old life. Paleo means old in Greek. Zoic, zoo, animal life. So, life. So the Paleozoic Era is the era of old life, and it's from the beginnings of life on Earth. By far, it's the longest of the three ages of life. And it ends with the Permian event mass extinction about 248 million years ago. Paleozoic Era, and it's the age of fish and amphibians. That's when fish and amphibians are the cutting edge of evolutionary development. Hey, he's a fish, that's advanced. She's an amphibian, that's even more advanced. Then, from roughly 230 to 248 million years ago to 63 million years ago, we have the Mesozoic Era. The Mesozoic Era, you can see above in proper order, is the era of middle life. And the Mesozoic is the age of welcome, the age of dinosaurs and reptiles. In the Mesozoic era, Pangea breaks up. The world's climate tends to be warmer and moister than it is today. And you have in the three periods of the Mesozoic. In the Triassic period, you've got the reign of Dimetrodon and other sailback reptiles that might be warm-blooded. And then in the Jurassic period of the Mesozoic era, you've got Brachiosaurus eating from trees, and Stegosaurus, and the first flying dinosaurs, the pterodactyls, pterosaurs, even Archaeopteryx, which is a feathered dinosaur that looks like a bird. And we know it's feathered because of the fossil record. The same way we know that the ichthyosaur looks a bit like a dolphin, because there are impressions of the feathers left in the stone. Then the last era of dinosaurs, the last of the three Mesozoic periods, is the Cretaceous, where you have the bull-like Triceratops facing off against his enemy, the Tyrannosaurus Rex. If you're happy and you know it. Because they have little tiny arms. Now, why do Tyrannosaurs have little tiny arms? Because they don't need big arms. They have their mouth to do everything they want with. Yeah.
So what's the point of having arms at all?
They're vestigial. They're basically left over. Back when, in the earlier phase of the T-Rex is the Allosaurus from Mesozoic times, and they had bigger arms that could be used to claw. But I guess this particular variant of dinosaur evolved in such a way that as time went on, it just didn't use its arms as much.
Well, actually, Tyrannosaurus' arms were actually long enough to push itself up a little bit, and then so it can get its feet under it if it fell down.
Well, that's good. But I wouldn't want to see a T-Rex trying to do push-ups. That would be sad. I think it would roll itself.
That'd be kind of funny.
I
think
think
that's
that's
Then they got the phenomenon.
That's hilarious. No, that's good though. I didn't know that. And some people theorize that all dinosaurs had feathers. We just don't know about many of them. So T-Rex's arms would look like chicken wings. You know, you've got this massive, giant mouth and little tiny chicken wings. Don't go to Buffalo. Bad place. Now, you also have in the Cretaceous, the end of the Mesozoic era, the giant pteranodon, which is a huge flying pterosaur with a big spike on its head that helped it turn in midair. Now, the end of the Mesozoic is another mass extinction. Hey, what's that? And apparently my wife said, because she came in and saw this drawing, that there were many memes about this.
About what?
Yeah. You've got Tyrannosaurus fighting Triceratops, and suddenly they both look up to this shiny thing in the heavens going, hey, what's that? BAM!
What a huge.
Well, what it is a nickel iron asteroid the size of Mount Everest that slams into the Earth at ridiculous speed. Ludicrous speed, really. And what happens is that so much particulate matter is thrown up into the atmosphere that there is a winter that lasts decades, maybe centuries. The sun is blocked out by all the gunk in the air. Now, you know what that's going to tend to do? It's going to kill the plants, most of them, because plants eat sunlight.
No, they don't.
Yeah, they do.
No, they don't.
Yeah.
You're lying.
That's right.
Second.
You're a chlorophyll denier! Denier!
Yeah, okay.
Yeah.
What is this? Okay, prove it then.
In any event,
Yeah, that's what I thought.
in any event, for everyone but Cruz, you should follow along. Without the sun, most plants die. Without plants, every food chain ends up toppling like a Jenga tower. It just doesn't work. Yoink. Ah! No, food chains won't work because there's no plants for rodents to eat, and without rodents to eat, most big life forms. So there's another thing that happens just after the meteor impact that kills the dinosaurs. Because some people say, well, maybe the dinosaurs weren't killed by the meteor. Maybe not. But just after the meteor impact, there's what's called, oh, by the way, the meteor hits near the tip of the Yucatan Peninsula and forms the Gulf of Mexico crater.
Well, that's the crater.
That's the crater. So, Puching, it hits there. Now, halfway around the world in India, what we now think of as India, are what's called the Deccan Trap eruptions, which is the Earth's crust literally ruptures, into dozens of hundreds-mile-long rips that exude magma and poisonous gas from the mantle. And that between the asteroid, gentlemen, between the asteroidal impact and the Decatrap eruptions, anything larger than a mouse basically dies off. So the largest life form on Earth after the combined asteroid impact and Decatraps is a mouse.
Wow.
That's what's called. So when you have that begins the era of new life,
Ratatouille.
of recent life.
Oh, I want a Ratatouille movie, but
Guys.
after the arc.
Yeah, just remember, Ratatouille, it's a dessert. Tasty rodentine dessert. You got to do something with the rats, otherwise they'll eat you.
I have a rat as a pet.
You do. What's his name?
I don't have a rat.
You don't have a rat. Okay, I'm sure if you had, he'd be
I have a
very
frog, but
clean,
he's kind of a rat.
friendly rat. Yeah, frogs and rats, they're so much alike.
Yeah, I mean
It's like the book, Why Hawaii and Norway Aren't Near One Another. How to Kill a Rat with an Oboe.
are you a rat?
How to kill a walking
You rat,
with a
you rat.
Oh, you wearing a wire?
And then the rat takes it with his teeth and rips his throat out.
Yeah.
No, that's that. You know what shurikens are? Flying stars? Well, these are ratkins. In any event, we are back from the world of rats into the world of us. When the explosion occurs, the Decatraps occur, the age of recent life begins. Recent Cenozoic. And the Cenozoic Era, which is still going on, is the age of birds and mammals. Now, during the Cenozoic, fairly recently actually, something happens in geology which is going to change the climate. South America and Africa were separate from their northern neighbors. Between South America and North America was the Strait of Panama, through which an equatorial warm water current flowed. Between Africa and Eurasia was the Strait of Suez, of Sinai, through the Tethys Seaway. So around the entire equator are a series of warm water currents that keep the climate stable. But then, thanks to plate tectonics, North and South America kiss, and the Strait of Panama becomes the Isthmus of Panama, blocking the current. And Africa and Eurasia kiss and form the Sinai Peninsula, again confiscating the equatorial warm water current. When that happens, we enter a period of profound climate instability known as ice ages. On more than one occasion, a solid mile of ice was right here, where I stand, where you sit. More than once, solid mile, surface of the earth, ice, surface of the ice, over a mile up. Ice ages are an example of climate instability. We are in an inter-ice age period. One of the benefits, if global warming were a thing, is that it's fighting off the ice age. It's entirely possible that coal power in the 1800s fended off an ice age, which by now could have destroyed human life and human society. We are between ice ages. So at some point in the future, there's going to be another giant ice pack over our heads. Another reason to go into space. Because if you are in space, you don't have to worry about ice ages. In fact, our species, according to evolutionary theory, is a product of ice ages. Here's how. The early human ancestors were arboreal primates, forest-dwelling, brachiating, that's knuckle-walking, apes. And we lived in the trees. But then an ice age occurs, which dries the global climate around 3 or 4 million years ago, and suddenly the trees die off and we have plains take their place, big open flatlands. Now some of our ancestors go where the trees go and they end up being an evolutionary dead end, they all die off. But some of our ancestors say, which means if life gives you lemons, make lemonade. In other words, we're going out into those grasslands, and we're going to triumph. So the ape men do that, and they form what will ultimately become human beings. Now, before we go into that story, let's look at the different types of animal life. So next page. Oh, just to be clear, When an entire race of things dies out, it's an extinction. When a whole bunch of races die out at the same time, it is a mass extinction. So now we're on the next page. We got 6 possible answers plus fish, which I didn't include. Number 50. What are creatures who lay eggs, have 6 to 8 legs, have exoskeletons, and live on land and water and in the air, like dragonflies? What are they called? Yeah, you.
I don't remember.
Look at the 6 things and tell me.
What do you think it says?
Insects.
Thank you. Insects! No, we're not playing Geopardy. And I'm not shaving the mustache. Okay, what are creatures? This is not on here, but you can figure it out. Okay, so we've done insects and basically arachnids. What are creatures who lay soft eggs in the water, breathe water as youngsters and as old creatures, and have scaly skin? What are they?
Yeah,
They're not one of these. They're another thing.
They soft eggs in the water.
Yeah, they breathe water, they have scaly skins.
Fish.
Yes! They are fish! Okay, Miss Mallory, I'm going to ask you this one. What are creatures who lay soft eggs in water, breathe water as youngsters, and air as adults, and have soft and slimy skin? What are they? Amphibians, like frogs. Okay, number 52. Miss Jaylee. What are creatures who lay leathery eggs on land, breathe air, and have dry and scaly skin, and have cold blood, such as crocodilians? Reptiles. That's right. Okay, this is where it gets a little tricky.
Yeah.
Miss Bird. What are creatures who lay leathery eggs on land, breathe air, have dry and scaly, maybe feathery skin, and may be warm-blooded, like the Allosaurus? What are they? Dinosaurs, that's right. Not all big reptiles are dinosaurs. Dinosaurs have hip bones. Dinosaurs are like transitional stages between reptiles and birds. That's a good way to think. 54. Miss Mary? Miss Oxford. It's the mask. It's not like I could easily recognize anyone with these masks on. 54. What are creatures who lay hard eggs on land, breathe air, have feathers, and have warm blood like eagles?
Birds.
Yes. And finally, what are creatures who give live birth, whose females lactate, who breathe air, have fur or hair, and have warm blood like cats?
Me. Are you ready for this one? Mammals.
Mammals. Yes, mammals. Now, you want to understand how bad committees are? The platypus was a creature designed by committee. It's got a duck's webbed feet and a duck's bill. It's got a beaver's body and tail. And it lays eggs.
No.
This is a creature that is a bermammal, or a mammallard. It is a combination of mammal and bird. I don't understand. The platypus to me is an example of how God has a sense of humor. Yes.
I think the first time a platypus was discovered, I think people thought it was like some stitched up animal.
Yeah, they thought it was a scam, like the Piltdown Man, which was a fake human ancestor concocted by a bunch of scientists who wanted to make a name for themselves. Yeah, that's funny. But it's true. Okay, now we're going to cover the first 2 human ancestors, and then we're going to be done for the day. According to evolutionary theory, between 3 and 4 million years ago, a man-like ape appeared. He was around 3.5 feet tall. He had brow ridges, almost no head above those brow ridges. The skull sloped almost straight back. Little tiny face, no chin, and a snout rather than the nose and mouth separate. This creature was called the Great Southern Ape from afar, or Australopithecus afarensis. Now, Australopithecus had other variants. The Africanus was a hunter. Australopithecus boisei was a plant eater. But we think that Australopithecus afarensis is the last of the man-like apes. Now, he was a tool user, not a tool maker. He did what chimpanzees do. Chimpanzees, if they walk by a termite mound, which is usually huge in Africa, will look for a thinner stick than this, and they'll wet it with their mouth. And then they'll stick the stick into a hole. leave it there for a little while, and then slowly pull it out. And what it is a termiticle. Nom, 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 nom. That's protein. The stick will be covered by termites, and they've got free protein right there. Stick a wet stick into a termite mound, pull it out. Termiticle. It is cuisine as far as chimps go. Chimps will not make tools, but chimps will use them. So this is the last of the man-like apes. Then we shift a little forward to a period of what? About 2.5 million years ago to just over 1.5 million years ago. We have the first of the ape-like men. His genus is no longer Great Southern Ape. It's no longer Australopithecus. It's Homo. Homo means man. We're going to have fun later when we do Homo erectus. So, genus Homo, he's a man. That's what Homo means. It means man. And species is Habilis. This guy is handyman. Like Tim the Tool Man Taylor from the old sitcom. Handyman makes tools. Yeah. So what he does is he'll take the right kind of rock and flint. Fleck, 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 chip. Fleck, 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 chip. And he'll, over many hours of time, turn a couple of rocks into a tool that makes a sharp stone knife or axe. If it's an axe or a knife, you could cut anything with a newly cut stone knife. Properly made, they're as sharp as a razor. But they lose their edge quickly, so you've got to chip off some more. Homo habilis made these things. They're not easy to make. If they were pointy, you could use it as an edge and cut into something. So the huge difference, let's look physically, and then I'll take your question. Homo habilis still has a snout rather than a nose or a mouth. He still has heavy brow ridges. But he's slightly larger, closer to 4 feet tall, and he's got more of a forebrain. It's beginning to develop. And it's the forebrain, the brain above your eyes, where you keep your personality, where you keep your humanity, where you keep yourself. So he's beginning to develop that human-style brain.
Oh, why do they have the 4 ridges above their...
To protect the brain from attack. Brow ridges are something that apes still have. You hit a human being in the head, and you hit them in the wrong spot, you'll kill them. You hit them in the temples, they're very weak. Brow ridges are designed to offset this. We lose them, we become more fragile, but we also get a brain that develops guns. And in the end, guns are better than brow ridges. Remember that as a quote. Guns are better than brow ridges.
So was this just an art error, or were their heads actually like slanted up?
No, they were a bit slanted. I mean, look, a normal man's head has this sort of area between the crown and the back that slopes up slightly. So they have a bigger head. But it's not our shape yet. It still has, it's about 1/3 to 1/2 of the area above our eyes, and then it goes back.
It's not round. You don't have to spend an hour drawing to fix
Grind
it.
down.
Right. There you go. So that's where we're going to leave it. The first of the man-like apes, as opposed to the last of the man-like apes, first of the ape-like men. And he's a man, in part, because he makes tools. Makes them. We'll continue next time. You may talk quietly among yourselves. Have a good day.